Guys, very good evening to all of you, everyone over here. Just welcome to the live stream only onto the YouTube channel Unacademy Computer Science. So yeah, everyone, how are you all doing? Hi Sairam, very good evening. Harshit, very good evening. How are you all doing, guys? How is everything going at your ends? And whosoever hasn't shared this live stream yet, guys, do please share this live stream with your friends so that in case they want, they can also join in the class and start with us for today. Okay, I'll be starting on with like what right away Unacademy is offering you in terms of the batches and everything. Okay, so you can save to 50% off with your 4 months of free extensions for GATE and ESE, CS and IT subscriptions. Okay, you can join our Prarambh and the Vishwas batches for the GATE and PSU 2025 and 26, which is going to start on 30th of December 2023. Okay, duration is going to be 12 plus 2 free months. Okay, you are having two kinds of the batches, plus and the iconic. Duration for them goes as in like you are having 12 plus 2 free months, 15 plus 3 free months, and 24 plus 4 free months, right? That's what's the duration right away goes here. And apart from that, you are even having the price like what you exactly have to pay. So here are all the mentioned out payouts which you have to give in terms of the plus and in terms of the iconic batches. Okay, so the new batches are going to start from 30th of December. Okay, till then you can enroll into these batches, go ahead and take the complete courses for the same. Okay, for any of the details you can call on to 8585858585 and reach out and clear out your all of the questions and queries over there. So the Prarambh batch is going to be starting for the GATE and PSU 2025 for the CS and IT. It's going to start on 30th of December. Okay, that will be Hindi plus English CS, and that will be your batch number B. We will be starting on with the database management system. Okay, onto the same. Next, talking about the Vishwas batches for GATE and PSU 2026 for the CS and IT. It's also going to start from 30th of December. Hindi plus English, CS, and the batch number B. Okay, and that also will be starting on the database management system. For the DS and AF, the Prarambh batch, you have the like starting for the GATE and PSU 2025 for the DS and AI. It's going to start from December of 30th. Okay, Hindi plus English, DS and AI, and batch number A. You'll be starting on with the database management system. And if I talk about the Vishwas batch for your GATE and PSU 2026 DS and AI, you have the starting on 30th of December, Hindi plus English, and that will be again DS and AI batch number A. And you'll be starting on with the database management system for the same also. Right, so this is all what you are getting offered in terms of the batches which are right away going at Unacademy. So guys, in case you take up the iconic subscription, so you get up the these list of the books delivered at your home within 15 days of time. Okay, you get the books about digital logics, operating system, programming and data structures, theory of computation, computer networks, database management system, compiler design, computer organization architecture, discrete mathematics, algorithm, engineering mathematics, and aptitude. So you have like all of these books delivered at your home within 15 days of time in case you take up the iconic subscriptions. Okay, so yeah, nothing can stop you from chasing your GATE, CS and IT dream, everyone. So you can get started with a no cost EMIs and a 0% interest onto the loan for as low as rupees 3,599 per month. The process is very simple. You get the approval in 2 hours, you get the minimal paperwork and a flexible tenures also. So right away, like daily scholarship tests are also going on, guys. You can just take this test completely for free and you can get up to 50% scholarship for this respective test. Okay, it is of 15 minutes, 15 questions. You can take this test anytime and anywhere, maybe from your app or from your desktop also. And you get the immediate discount based on your performance. So in case you got the rank 1, you'll be getting 50% discount. In case you get the rank between the top percentiles, okay, 30% discount, top 10 percentiles 15%, 90% will be getting the 10% of discounts. So these are all the people who have already cracked out GATE 2023 of Unacademy. So many congratulations to all of the Unacademy learners for the same. Okay, perfect everyone. So we'll be starting on with your machine learning today, like with the things for their stuffs. So yeah, everyone whosoever is here, just first will drop me a hi or drop me a yes in the chat box, guys, if you have joined in the live class. Just a minute. Okay, yeah. So I don't know why the camera is not okay. Just a second, everyone. Hopefully it's better, right? Yeah. Fine. So let's start with the class today. Okay. So everyone whosoever has joined in. Okay. Hey Kabir. Fine. So guys, today we'll be discussing about your dimensionality reduction. Okay. Like exactly what dimensionality reduction is, what do you do into that respective thing, right? What it is used for. We'll be discussing all of these respective things into this particular class of today. Okay, so what I'll do, I'll just take you towards the OneNote and we'll be starting with that only. Just give me a second to open the OneNote. Okay, just 1 second. Fine guys, so we'll be starting on with this topic of today, that is your dimensionality reduction, right? So I'll just put on the heading also over here. Fine, let's start for today, everyone. So, okay, let's start with dimensional reduction. So, see, like, I understand this particular thing, everyone. Okay, what exactly it is. Okay, what exactly dimensional reduction is and what do you can, like, what exactly you can do with this. So, whenever you have to convert maybe a higher dimension data set to a lower dimension data set. Okay. So in that particular case, you use of the dimensional reduction, right? It is a way with the help of which you can convert the higher dimensions data set into a lesser dimension data set, ensuring that it is going to provide up the similar information. Okay, that is what dimensional reduction exactly is. So right, whenever you are working on with the data, so like many times you get across this kind of a problem where you have to reduce up the dimensions because of the very large dimensions, your data is not working properly or some kind of stuff like that, right? So in that respective case, you can just simply use up this dimensionality reduction technique and you can just work with the same. Okay, so that is where you just use this particular thing. But yeah, there's one condition, that it should not affect your like there is one condition, should not affect your information which is getting provided provided to you by that complete data set, right? So whatever you are getting, like you're providing with the data set, there should not be any problem, any kind of the information should not be there, or any kind of a thing like that should not be present, right? Yeah, Harshit, feature scaling method using PCA. Yeah, right, that kind of a, like, yeah, right, Harshit, that kind of thing only over here, right? So yeah, that is what dimensionality reduction everyone means over here, right? So whenever you want to obtain up a good fit into your model, right? So what exactly we require to do? We need to have up a good fit into our model, right? So whenever you want to get a good fit into the model, right? In that respective case, it helps you to provide a better fit as well into a predictive model while you are solving up a classification and regression problems. So dimensionality reduction, it is a technique actually, okay? It is not something, it is not an algorithm which you can put either in the regression or in the classification, right? Or maybe in the clustering. It's not a algorithm, right? It is a technique, right? It is a technique which you use in generally for reducing up the dimensions of your data. Fine. So generally whenever you are having up a high dimensions data, kind of a data which is like having a speech recognition data, maybe, or maybe any bioinformatics kind of a data, right? So whenever you are having these kind of the data, at that particular place you work with this dimensionality reduction, okay? And that is a place where you just go ahead and like try to reduce up the dimensions of your data. So everyone, am I clear with first of all what dimensional reduction is and where do you use it exactly, like where it comes into the use? Am I clear with the same stuff to all of you guys? Yes, everyone, am I clear with the stuffs to all of you? Okay, Harshit, fine. Okay, pretty fine everyone. So this dimension reduction technique, it is as well further classified. So you are having two classifications for the same. So the very first thing where it is completely classified is your feature scaling. Feature scaling, right? And second where it is classified is your dimensionality reduction. Dimensionality, and here goes your reduction. So it is classified into these two parts, okay? Now this dimensionality reduction which we are talking about, this is also further classified. You classify this dimensionality reduction also. Hi Vivek, very good evening, very good evening. So this dimension reduction which we were talking about, it is also further classified, okay? So it is classified onto the components factor based. So the very first where it is components factor based. This is the very first thing where dimensionality reduction is exactly first of all classified, and second is a projection based. Projection based, right? So yeah, see, this is like where dimensionality reduction is also further classified, okay? So first it is classified in the feature scaling and dimensionality reduction, and next is it is furthermore classified into components factor based and the projection based, okay? Now these things also have their subdivisions, okay? So I'll just try to write down all of those subdivisions which we have for them. So you just apply this missing feature scaling whenever you have feature scaling whenever you have to deal with the missing value, okay? Whenever you have to work with your missing value ratio, the very first thing, that is when you're gonna use your feature scaling. Okay. Next, you'll be using whenever you are working with the low variance. Okay. Third is whenever you're working with the high correlation. Okay. Next, you will be working whenever you are having that random forest problems. Okay. So whenever it comes about having a random forest problem, so in that case you will be using up your feature scaling technique into that particular case. Okay, random forest. And there are two more things which is called as one is known as backward feature extraction. Okay, there is one thing which is called as backward feature extraction, and next one is about your forward feature extraction. Yeah, so that is where you just use out this feature selection techniques. Okay, these are all the places where you use them for the missing value ratio, for the low variance, for high correlation, for the random forest, for backward feature extraction, and for the forward feature extractions. Okay. Hi, very good evening, KB. So yeah, these are the places where you use up your feature selection. Okay. Now, when I talk about your other option which we are having, the components factor based, right? So under this comes in your factor analysis. First of all, there is one thing which lies as known as factor analysis, right? Then comes your PCA, principal component analysis, right? And then we are having one more, that is independent component analysis. So I'll just write independent component analysis. So components vector based, this kind of your subdivision is worked for your feature and for your factors analysis, for your principal component analysis, and for your independent component analysis, right? These are all the places where you just use out this components factor based. Now projection based is also like used out when you are having isomap, ISO, MAP, Harshit linear. Yeah, right, Harshit. You can just use it whenever you just have that linear discriminant analysis. Na, there also you can surely use this out, right? You can use this. So yeah, working with the projection base, so yeah, here you have this isomap, this TSLE, this UMAP. Every of these problems now you are just dealing with the projection based thing over here, right? This is what exactly comes and lies under this division of your dimensionality reduction for the feature scaling and like dimensionality reduction technique. It is like divided into two parts, feature scaling and dimensionality reduction. Then these are further subdivided and worked for the same. So yeah, everyone, am I clear about this, that what exactly you come in with the dimensionality reductions technique? Right, what exactly you have under this and what lies under like whenever you have to use feature scaling, what things you're gonna do whenever you have to be working with the components factor based. So what things will be coming onto the place. Are you all clear with the same? Yes, everyone just confirm me out. Are you all clear with this task which I have just said over here? Yeah, guys, if you can just help me out with the confirmation, is it clear to all of you? Okay, now let's try to understand what whenever you are just dealing with the high dimensional data, right? So what problems occur in between? Let's try to deal with them. Let's try to solve that respective thing. Okay, fine, Akul, fine. Fine, so let's see that what problems you face whenever you are dealing with the high dimensional data. Right, so see, if the dimensionality of the input data set increases, whatever the input data set we are having, if the dimensionality of that gets increased, so any machine learning algorithm or the model, it becomes more complex. Obviously, it's the absolutely correct thing, because as the dimensionality of data increases, at the same time the machine learning algorithm or the model, it becomes out more complex. Right, so now next, as the number of the features also increases, there are the number of samples which get increased proportionally. Absolutely right. As soon as the number of the features are increasing into your data, number of your samples will also get increased, right? And whenever this number of samples will also get increased, so in case you might have a chance of the overfitting also too much. Fine. So see, like in that respective case, whenever you train up the model onto the high dimensional data, so that respective data, it becomes overfitted, and that results out in the poor performance. Okay, so as to just avoid that overfitting and the poor performance into your data, you just have to work on in the dimensionality reduction of your data. You just work with the dimensionality reduction, and you can just very simply and clearly go ahead and work about the same. Okay, so yeah, that is what dimensionality reduction is exactly used out for. Fine, so am I clear with this to everyone? Yes, guys, are we clear with the same? Like, why do you use a dimensional reduction? Why is it important for you? Because you never want that your data should become give you poor performance, or it should become overfitted or something like that, right? Okay, Harshit. Okay, Akul. Fine, fine, guys, fine. Now let's try to understand a little bit of what are the benefits. Okay, let's try to understand about the benefits of this dimensionality reduction. Yeah, so everyone, guys, according to you, what are the benefits of dimensionality reduction? You all let me know. According to you people, what are the benefits of using up the dimensionality reduction? Because right away I told you where it comes as a problem, right? So just help me out, what are the benefits of the dimensionality reduction? Okay, Akul, fast analysis. Okay, okay. Yeah, it helps you to do the faster analysis because of the dimensions get reduced. Absolutely fine. What rest? What next, everyone? Harshit reduces the feature, hence makes similar. Our dataset reduces the problem of overfitting, right? Absolutely reduces the problem of overfitting, right? So see, like by reducing dimensions of the features, whatever the space we require to store the data set, that also gets reduced. Absolutely, because when we will be reducing dimension, the space will also get reduced. So yeah, that is the very first thing, that is a reduction of the space, right? Next is a very less computation training time is required for reduced dimensions of features. So yeah, you require a less computation training time. Okay. Third is the reduced dimensions of the features of the dataset. They help in visualizing of the data quickly. Absolutely, they help you to visualize of the data very quickly, right? And the next is that it removes the redundant features by taking care of the multi-collinearity. So yeah, it absolutely will help you to take the care of the multi-collinearity, because it helps to remove the redundant features, right? Yeah, these are these are a few benefits, guys, which you exactly have in terms of whenever you work with the dimensionality reduction. These are a few benefits which are over there, and they really help you out to work with your data very clearly, very easily also. Fine. So yeah, am I clear with that, everyone? And even just allow me a minute, guys, I'll be back. Okay, till the time just let me know are you all clear. Just allow me a minute, I'll be back here. Yeah, okay, just a minute. Yeah, fine. Okay, Java, ma'am, I'm beating third year, but I'm interested in CS. Can I see this? Yeah, absolutely. Yeah, absolutely, Java, that's not an issue. Anyone who just want to learn about machine learning or data science, right? Any one person can, and any of you can watch this out. There's no such restriction for anyone, like if it's pursuing BTech, then only you can, or anything like that. Absolutely, you can be here. Okay, fine, everyone. So yeah, we just discussed about what are the advantages of, like, benefits of your dimensionality reduction, right? We just have discussed out. Now let's talk about what are the disadvantages, right? Now you all think and let me know, according to you, what can be the disadvantages of using this dimensionality reduction, everyone? Okay, okay, Chaval, that's very nice, very nice. So maybe you are having a lot of interest in machine learning and data science, right? That's very nice. Yeah, everyone, so let me know, according to you guys, what are the disadvantages of dimensionality reduction, everyone? Think it and then let me know, everyone. Java learner, but sometimes I feel it is hard. No, not exactly, it is not hard in case, but yeah, it like, yeah, once you're gonna like read it for the very first time, you might get it a little difficult because it's a lot of conceptual things you have over here, right? And just because of those conceptual things, it becomes sometimes a little bit difficult or maybe a kind of a confusing to study. Absolutely, but yeah, once you're gonna study it too properly, you won't find any difficulty into this, right? Akul, accuracy may be an issue. Okay. Okay, about the accuracy, what other things you people think can be the disadvantages? So understand, try to listen me out, everyone. Talking about what can be disadvantages of dimensionality reduction. See, there can be some of the data which may get lost because of the dimensionality reduction. Okay, there might be this might happen that there may be some data which may get lost because of the dimensionality reduction stuff, right? And might happen that it is important for you in that important in terms of your data putting in the model or making the model or applying that respective thing, right? Okay, Harshit, it can make our algorithm more simpler, hence may lead to underfitting. Okay, underfitting, right. And second is when you work with the principal component analysis, that PC dimensionality reduction technique, right? So what happens that the principal component which you are having that requires to consider are unknown. That PC components with which you are gonna apply up this PC dimension reduction, right? So that principal components they require to consider that are unknown. So maybe into that respective case only it might help you out. It might just make a difference or differ in that particular case. So yeah, that is where is one more disadvantage of your dimensionality reduction, guys. So am I clear with the same? Like data outliers. Okay, fine, Akul, fine. Okay, fine, Harshit, fine. Okay, pretty good. Fine. These are now what are the approaches? As I told you the feature selection onto that map which we were making above, I told you about the feature selection, right? So what exactly feature selection is, guys? It is a process where you just try to select the subsets of the relevant features, okay? Whatever the features you are working with, you just try to select the subset of those relevant features and you just leave out to the irrelevant features which are present into your data set. Okay, I hope you are trying to understand. So what happens in the feature selection? It is exactly a process where you just leave out onto the process of, you just start with the process of selecting the subsets of the relevant features, right? And leaving out the irrelevant features which are present into your data set for building the model of high accuracy. That is something which is your feature selection. Okay, so generally if you want to say in other terms, you can say that feature selection is a method. It is a way where you just select out the optimal features from the input data set, right? Whatever are the features required, and maybe you can say the optimal features. It is a way for selecting those features from the input data set, and that is it, what feature selection exactly is. Okay, so just it is a way where you select the optimal features from your input data set. So the methods which are used for feature selection are like filter method, wrapper method. You're having a lot of kind of those methods as well which are there. But before that, let me know, like are you all clear with the feature selection thing, everyone? Are you all clear that what feature selection is? Where you just try to work with the selection of the optimal features from your input data set. I'll even just put down the heading also, so that it becomes maybe easier for you. Okay, fine, Harshit. Okay, so once we have learned about the feature selection, we are further gonna start on with the methods of that, right? So the very first method that comes is about your, one second, I'll just try to make it little bit more clear. The very first one that comes is about your filters methods. Filters method, that is the very first thing, guys, that comes up over here under the feature selection. Filter method, right? So what happens into this filter method? Into this method, whatever the data you are having, that gets filtered. Okay, and whatever the data you are having, like that the data which is getting filtered, so for that there is a subset, right? And that subset, it only contains about the relevant features, right? So once your data is filtered and a subset, like it only contains about all the relevant features that are taken from your data. So for this filtering technique, what methods do we use? We use a method which is correlations. We like use this correlation for filtering up your data and containing all the relevant information into a subset, right? We use one more thing which is chi-square test. Now maybe you haven't heard this name yet, because this chi-square test, this comes under your statistics and probability part, right? So once you'll be starting with the statistics and probability, I'll let you know about this in detail also. Okay, next is we have a thing which is called as ANOVA. Okay, and a lot more you are having for the filter methods, but yeah, correlation, chi-square test, these are some things which you generally used in for thing. So under this filters method, your data which you're having, that gets filtered. A subset is made that is containing all the relevant features, that is completely taken. Fine, that is what happens up under this. Next method which we talk about is your wrappers method, which comes under your feature selection. Wrappers method. Okay, now under this wrappers method, what happens? It generally has up the same goal, right? As a filter method, the goal is exactly same, that it takes a machine learning model for the evaluation, right? So some of the features which are there into this particular method, those are sent out to the ML model for the evaluation, for maybe to evaluate the performance, whatever is there, right? And whatever the performance which we are having, so exactly what happens there, the performance that we are having, it actually helps you to decide whether you just have to add those features or remove those respective features for the accuracy of your model. Because see, whatever we just do, at the end, it is all to feature to get the exact accuracy of my model. That is our end goal which we have to achieve in, right? Harshit, now I can also start a YouTube channel sharing ML content. Yeah, sure, Harshit, absolutely you can start in, and I would love to see you on YouTube sharing about the ML content. Absolutely. So yeah, see, the wrapper method which you're having, again I was saying this will have a same as a filter method works, right? What it will do, you will just have some features which will be given to the machine learning model for evaluating out the performance. So the performance is gonna decide, the performance is gonna decide that do you have to add those features or you just have to remove those for increasing up the accuracy of your model, right? So the method which we are having, that is more accurate than the filtering method, but yeah, it is complex as well to work with. So there are a few techniques which we use for the wrapper method. The very first one is your forward selection. Forward selection, the very first technique which we have in. Next, you all are having as your backward selection. So backward selection. And the very third technique which we are having up is bidirectional selection. Bidirectional, and again the selection, same part, right? So yeah, these are the three techniques for your wrapper method. So these are three common techniques which we use up into your wrapper methods for your this respective thing. Fine, right? Now after this, after wrapper methods, you are having the third method which is known as embedded method. So yeah, these are all the methods for your feature selection, right? Now the third method goes as your embedded methods. Embedded methods. Okay. Now when I talk about the embedded methods in detail, so these are helping you to check the different training iterations of the machine learning model. Whatever are the training iterations into my machine learning model, these are helping me to check those, and even they will help me to evaluate the complete importance of every feature. Excuse me. So yeah, these help me to even evaluate the importance of every feature which we have up under this respective method, right? So the common techniques which we are having in the embedded method, those are maybe you might not have heard about the names also, right? But those are lasso techniques, elastic net, you have ridge regression, right? So yeah, these are all of the techniques which you have under the embedded methods. These are just used to check the different training iterations of a machine learning model and evaluate about the importance of every feature. That is it, what embedded methods are exactly helping you to do, right? Now if I talk about the feature extraction, before that, just confirm me everyone, are you all clear till this particular place? Feature extraction. Yeah, everyone, are we clear till this particular place? Okay. Now, what comes under the feature extraction, guys? So this is a complete process where you transform of the space. Right, I'll be Akul, after the machine learning, I'll be starting with mathematics, and there only I'll be explaining you all of these methods. Okay, I'll be explaining. So yeah, we were talking about the feature extraction in detail. So see, this is a process where you transform of the space containing many dimensions into a space with fewer dimensions. Now see, whatever the data we are having a spaces also into that particular, right? So under feature extraction, you just try to transform the space containing dimensions into a space containing few dimensions. You have many dimensions with the space containing. You just try to convert them to a few dimensions, right? So this particular approach which we are having, that is useful whenever you want to keep the whole information, right? But yeah, generally use of the fewer resources while you're processing up this particular information. Fine. So yeah, this is all like where you just have to work with the space containing many dimensions to reduce them to the space with the fewer dimensions. That is what you work with the feature extraction. Now, the methods which you work under feature extraction are your first of all PCA, Principal Component Analysis. Second is your, I'll just write that in detail, Linear Discriminant Analysis, right? Next you go with one more thing is there, that is known as Kernel PCA, Principal Component Analysis. And then you just have this particular thing, Quadratic Discriminant Analysis. So yeah, these are the four most used techniques while your feature extraction. These are the processes with the help of which you try to do up your feature extraction. Fine. So everyone, am I clear till this particular place to all of you? Everyone, am I clear till this particular place, guys? Okay. Now, what are the different methods for dimensionality reduction? For dimensionality reduction, there are a few methods which are generally used out. Okay. You have principal component analysis, PCA. You do the backward elimination, forward selection, right? You work with the missing value ratio, low variance filter, high correlation filters, random forest, factor analysis. Will be discuss. Yeah, Harshit will be discussing them in detail. Especially we'll be discussing PCA in detail. Not right now, not right away. No, maybe not today. Also, we'll be discussing about PCA in detail tomorrow. Okay. So yeah, this what I was talking about, this dimensionality reduction, right? So yeah, the techniques which I was talking about, which were like your PCA, your backward elimination, forward selections, missing value ratio, low variance filter, high correlations, factor analysis, random forest. So these are all of the different techniques which are used in for your dimensionality reduction, right? So yeah, guys, this is what all dimensionality reduction exactly is. Okay, this is what dimensionality reduction is. These are the things that you have under it, right? These are the things which you have to take care. I told you about the advantages, disadvantages, everything. So all of you, am I clear in this particular place, guys? Any questions, any doubt? Linear discriminant analysis is not covered, but it is given in our syllabus in supervised learning plan. Yeah, Harshit will be covering about this linear supervised tomorrow. Okay, this is linear analysis, discriminant analysis, PCA, even all the factors which are listed right away. I'll be discussing all of those factors in detail tomorrow with you all. Okay. Yeah, fine everyone. So just confirm me, like whatever we have discussed till now, are we clear with all the same? Because that is what we had in for a dimensionality reduction. Now talking about PCA, linear discriminant analysis, right, factor analysis, backward propagation, correlations, everything we'll be discussing all of them in the detail in tomorrow's class. Fine. So let me know, guys, in case you people are having any questions which you want to ask me out. Any questions, any doubts, everyone, which you people want to ask me out? Right, so we will be discussing about the forward selections, right, backward elimination, and your low variance filter, high correlation filters, random forest. We'll be discussing about all of these in the details in the tomorrow's class. Okay? Okay, fine, Harshit, fine. Thank you for the confirmation. Fine, so guys, in case you people do not have anything to discuss in for today, I'll be closing up the session as of now. Okay? And I'll be again seeing you tomorrow at same time, 7 in the evening, with the further discussions about all of these topics. And everyone, now just try going through your syllabus once and try checking out what if there is anything which is left out, because we just have came to an end of the machine learning. Okay, so just let me know tomorrow in case we are left out with anything to discuss apart from this PCA and everything in detail. Okay, so hope to see you all tomorrow same time, right? So thank you everyone for joining this class. Thank you guys for being here. See you all tomorrow, same time, 7 in the evening, with the further explanations about the same and some more new topics. And thank you everyone. Take care and have a great evening ahead, all of you. Bye-bye and take care, guys.